Yeah, I am going to show how to construct a deep neural networks in deep learning for object detection. Here you can see the structure of the deep neural networks. You can see the different layers like convolution, reloop, pooling, and fully connected layers. Based upon these layers only we can create or we can generate the deep neural networks for detecting an object. Today what type of object I am going to detect means I am going to detect a object as stop. The stop signals only I am going to detect. So in order to detect the stop signal, first we have to generate a database. So in order to make the database we have to collect all the stop signal images, then keep it in a particular folder. I am collecting all the images and keep it in a folder as stop. So check it whether all the images having the stop signal. So outside of the database I am taking one image, that is the input of the image. Here also you can see you can find the stop signals which is located in the first. So before creating the deep neural networks we have to train all the images. So training is nothing but we are providing the predefined some input to the neural networks. So we have to provide the particular image and particular position of the object, then only it will automatically detect the position of the object in the output. So open the MATLAB, then provide the initial commands clc clear all, then close all. Then we are providing our input image im read of 1.jpg, then showing it figure comma im show of then just save the file in the object detect folder as deep. Then run the program. .jpg. Now we are getting the input image. Here we can see the stop signals. This signal only we are going to detect. Then before constructing that layers we have to provide the training should be in the form of tables only. So I am taking one variable sample1 is equal to open brace. I am taking the image 5 and 6 for training. So position is stop image 005.jpg comma stop image 006.jpg. Then take the image sample2. Then we have to provide the position of the object. I am taking the two images, that is image 005 and image 006. Then we have to provide the position of the images as a bounding box. That means 4 positions we have to pixel positions we have to taken left, right, and bottom 2. So here I am taking the position as 980 comma first image position 980 comma 393 31 comma 56. This is the first image position. Then the second image position is 1040 comma 354 comma 73 comma 72. And this is the second image position of the object. These are the two images I am taking to train the neural network. Then provide the path of the image. im directory im dir is equal to, we have to copy here and full file, paste it here. I am giving the path position. Then we have to provide the training options. Option is equal to tra option is equal to tra INING OPTIONS. Steepest descent gradient method FGDM, comma, minimum patch size PATCH. So patch size comma 32 comma initial running rate, initial land rate for a T only power minus 6 comma max epochs CHS 20. So this is the training option. SGDM mini patch size 32 cross 32 images only we are giving as a training. Initial land rate, okay, then we have to train the images. Train is equal to train RC NN object detector, object detector of, we have to provide the we have to provide the training as a table, so we have to create one table. Table is label is equal to table of sample 1 comma sample 2. So it should be in the form of matrix. So label. Now again next we have to provide the neural network. I am giving as a PP. Again options, comma negative overlap range, G comma 0 to 0.3. So I trained the neural network as an object label, VP options, VP options, negative overlap range, okay. Now I trained the image, trained the neural network. So here I am using this is the neural network structure PP. So I have to load it. So again I am loading it, load PP. So this is the position of the image and corresponding label. This is the neural network, this is the training options. Now we can train the neural network. So let me run it. You can see the command window. Yeah, I think it's going well. Now first step is extracting region proposal from two training image. Already we have given only 2 images. Just extracting that portion of the object in order to provide the train. Neural network classify the object in a train. Okay, now that network train completed. Then we have to classify, otherwise identify our object. Already we read our image, input image. Next generate the we have to provide the input, we have to provide the variables bbox comma score comma label is equal to detect of trained neural network TRAN train comma input image we are taken as a comma minimum patch size mini ATH SIC comma 32. Now we can This is the detect. Then we have to find the maximum score, SCORE comma, and the index equal to max of SCORE. Then the detected image, detect img is equal to, already we detect the bounding box. No, just we are just applying the bounding box to the particular object. Insert object annotation of which image we are going to inside, that is the input image a comma type rectangle comma b box, bounding box, sorry, b box comma annotation THION. Now we can show the detected object, detect img. So once again I am checking it, b box score label detect score, detect img insert object sorry, annotation a comma rectangle comma b box comma annotation. Okay, now we can check it. What I have done is just I have taken two training images and the particular position, then given the training option, then train the recurrent neural network, then just I check it based upon the training data. A is the input images, trNA is the trained data. I am taking just two images and training it. Then finally I am getting a B box. B box means that 4 corner values will be we are getting, that is the B box. Then just inserting that our input image, that is the A, which will be in the form of rectangle. Then just I am showing that image. Now let's run it. Run. Now you can check the command window. So extracting the training images, that position of the object from two train images, because I have taken only two training images from the images from the stop folder. So extracting the region, then it's training, it's to training. So I am getting the patch accuracy is 96.88. Patch loss is getting 0.1, so it's very less. So it will get some, it will take some time, because it's deeply analyzing the images. So I am pausing it. Yeah, now the training is completed. Now it's checking with our input images, and it's checking by 32 by 32 pixels whether the stop image is there, stop signal, that stop object is there. It is checking for the full image. If anywhere if it is found that stop signals, means the bounding box will be there. So it is getting, it's time taking more time. So why I am taking two images means here I am using the CPU. If I use the GPU only, I can give more images and I can train. No, it's some error is getting annotation. Oh, TATO. Okay, only. Oh, ANNOTATON. Yeah, we have to provide the annotation. So b box of index comma ist s print of confidence score. Then you are mentioning the annotation here. Now we can check the images. We can run the program once again. Run it. Check the command window. Extracting the region of 32 training images. It's making sound because GPU only best for training the images in deep learning. But I have totally 41 images, but I just used 2 images only for training because CPU's capacity is much low. It will take some time. So it's running with input image and checking the object symbol. You can see the command window. Now the testing is going on. Training completed. It's taking much time. Yeah. It's reading all the pixels of the input image. Yeah, finally we can got the output. You can see the stop signals. It's detected here. So this is the image which I given the input. So it automatically detect the stop signals from the image based upon the training. Now I given the 1.jpg. Now again I am giving one more image from the database. I am giving this image and naming as image 026. Input image 026. Let's check it, how the output is coming. Run it. See the command window. This is our input image which we given. It's taking time, so I'm pausing it. Yeah, now it's testing. Now it's checking all the pixels where the stop signal is present. Yeah, finally we can automatically detect the stop signals. So like that we can give other images. If we give the other images also, it is correctly detecting that is stop signal object. So this is what here we have seen today, how to detect the object and images. One more thing, you can have the doubt that how we are feeding this PP. PP is the recurrent neural network. This is the neural network which consists of more number of layers, as I said earlier. If you go for command window, if you type it in PP means you can see the layers. What are the layers I have used? An image, input, convolution, back pooling, ReLU, convo, ReLU, average pooling. Finally I am getting the classification output. So this is what in the first slide I have shown you. This kind of structures only we are generating the deep neural networks. So these 15 layers I have used to construct the recurrent neural network. Based upon the neural networks only I can detect the objects. You can see the neural networks. I am storing it as a PP. This is the layers, otherwise this is the neural network which I stored here. Then I just load it here. Here I am loading it. Line number 7. The same thing only again I am loading here. Train here. So based upon the recurrent neural network we can detect the object. Like that we can detect other kind of object like car, bus, like that we can detect it. Then we have to use the GPU instead of using CPU. By using CPU only I just given the 2 images and a particular label. And one more thing, we are given the training as a bounding box. Four values only we are given. Like that we are getting the output B boxes 4 output only we are getting. This is the 4 portions of the image. Pixel portion, that means left, right, bottom right, bottom left, like that. This is only we are giving the training input also. Like that we are getting the output in the 4 boxes. These 4 bounding boxes only we are giving it here in sample 2. I hope that you understand. If any doubt means you can call me or mail me, or you can contact me via phone, so I can help you. So this is the program which is generated, so you can use it for projects and other things. Thank you.